simplifying radicals can be applied in numerous things. This is like a stepping stone in terms of applications. And the reason why we're doing this now is because when we are using our quadratic formula, we're going to need to simplify our radicals. Before we even talk about actually simplifying, the first thing is you need to know perfect squares. So perfect squares are numbers that you can take to the power of 2. So it's in the form of x squared. So just to kind of give you an idea here, I'm going to create a chart. And I will give you a chart, and I will also put it on the corner of your desk. So you'll get one as well as you'll have it on your desk. So don't worry about writing the perfect square chart down right now. So if I have 1, this is going to obviously be 1 squared. Then if I have 2, 2 squared is 4. 3 gives me 9. You kind of see where we're going with this. I'm only going to go up to 10 right now, but your chart will actually go up to 15. But these perfect squares are going to help us to simplify our radicals. And the reason why is because we're breaking down the radical in terms of perfect squares. So some of you might be asking, okay, Mrs. Fish, I need help with the radical. A radical is just, I shouldn't say the square root sign, but in this case it will be the square root sign. It's technically the nth root of anything. It's just a special terminology that we use. Most of you will know it as the square root sign. But going on from here, let's actually talk about how to simplify. Again, we're going to need those numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So let's say that I have the square root of 20. So what you're going to do is it's kind of like a factor tree. You're looking for the perfect square, the highest perfect square that goes into 20. So what I do when I'm looking at this, and you'll have this sheet, but these are the first couple perfect squares. I go to the number 20 itself, and I go to the perfect square that's just below it, or above it, I should say in this case, since it's going numerically upward. So 20 falls within here. So what I'm doing is I'm starting here. So is 20 divisible by 16? No. So then I just keep working my way up. How about 20 divided by 9? No. And I just keep working until I find one. 4 obviously is my perfect square. So this gives me now 4. 20 divided by 4 gives me 5. This is the part that most students forget. When you break it down initially, those numbers still have that radical sign. Now I need to take, what is the square root of 4? The square root of 4 is 2. The square root of 5 can't break down any further. So I know then that my answer is 2 square root 5. And that's because it's the lowest form I can go off of that branch. So let's get a little bit trickier. Or I shouldn't say trickier, but a larger number. So let's go with square root 75. Just going to list these out. It'll be easier for you once you see the chart. It's right there. You can always look at it yourself. But I'm just going to write these down just as a frame of reference. I got to go a ways out to... All right, so 75 falls in between 81 and 64, so I'm going to work my way up. 75 divided by 64, no. 75 divided by 49, no. 75 divided by 36, no. 75 divided by 25, yes. And that is 25 and 3. So again, branching this out, still have that radical sign there. The square root of 25 is 5, and my answer then is that 5 square root 3. Now, let's have a little fun with this. Let's add in some variables. So what's happening with variables, let's say I have the square root of x to the 8th. What you're doing here with variables, this number, I know for a normal square root we don't have anything, but there technically is a number there and it's a 2. So what we do when we're simplifying exponents and radicals together in terms of variables is you're actually taking x to the power of that 8 divided by 2. Well, that's actually going to be x to the 4th. And that's my final answer. But you might be asking yourself, okay, that was an easy one because it was an even number. If I were to have, say, the cube root of x to the 7th. Now this one doesn't work out so nicely. X to the 7 over 3, well, that actually gives me, I can get it, the 7 over 3 is realistically 2 remainder 1. So what that tells me is that 2 of the numbers, or 2 of the x's are on the outside, and 1 of the numbers is still under the radical. So what I got here is x squared. I still have that little cube root there. And what goes underneath is x to the 1st. And again, that matches up, if you notice my color coding here, it matches up to the numbers 2 remainder 1. So let's do one more, but let's combine simplifying radicals with the exponents. So let's say that I have the square root of 80 x to the 3rd y to the 10th. Okay, so I'm looking for the perfect square. I kind of do these individually. So looking at this, well, I'm going to be here with the 80. 64, no. 49, no. 36, no. 25, no. 16, yes. 16 and 5, a lot of people with 80 want to go down to 4 right away because they know 4 works. But sometimes you gotta, that's why I want you to work your way up, because otherwise if you use 4, 20 can also be broken down, so you'd have to break down twice. So looking at the 80, we've got 4 square root 5. If we're going to look at the x to the 3rd, this is realistically 3 divided by 2, which gives you 1 remainder 1, which I'll deal with in a little bit. Y is 10 divided by 2, which is 5 remainder 0. So for my final answer, what's on the outside? Well, the 4 here is on the outside, the 1 and the 5. So I've got 4 x to the 1st, y to the 5th, square root now. Now I go for underneath. Underneath the radical sign is a 5, x to the 1st, and y to the 0. Since it's y to the 0, I'm not going to list it. So this right here is my simplification of radicals. Sometimes you'll get with bigger numbers with cubes, but it's the same process as when you're going through the 1, 4, 9, 16, but instead you're using not the perfect squares list, but the perfect cubes list. So that's simplifying radicals and variables.